Your life can change in the blink of an eye. Let Salisbury by Honeywell be there to keep you safe. We hear a lot these days about arc flash and the danger it presents to electrical workers in many different situations. Sometimes it seems like there are more questions than answers about this important safety concern. What is an arc flash? Why is it so dangerous? What can I do to keep safe? Today, we'll explore all of these questions and what you can do to keep safe on the job. We'll also look at how Salisbury by Honeywell can help you develop a complete program for electrical safety, starting with on-site safety assessments to complete head-to-toe outfitting of your staff with the appropriate PPE. We'll get you prepared for whatever electrical hazards your employees will face on the job while meeting all of the necessary safety standards. We'll also take the mystery out of the process and show you just how easy it can be to make the right decisions about your arc flash safety program. Let's get started with a look at what an arc flash really is and why it's so dangerous. Arc flash is a dangerous condition associated with the release of massive amounts of energy caused by an electrical arc. Arc flashes can be caused by various conditions including mechanical breakdowns or failures of electrical circuits, current overloads, or accidental contacts. This explosive condition includes a broad spectrum of electromagnetic energy, plasma, fragments of damaged equipment, and molten metal from the destruction of conductors at the point of the arc flash. What does this really mean to you? Consider the following. An arc flash event can generate temperatures reaching 35,000 degrees Fahrenheit. That's 4 times hotter than the surface of the sun. The molten copper that's generated during an arc flash often exceeds 2,000 degrees Fahrenheit and rapidly expands away from the source of the arc event, often being thrown a great distance from the source of the arc. Between the superheated plasma, the molten copper, and the overall force of the arc event, anyone nearby is at risk of serious injury or death. The effects of an arc flash can be devastating unless you're properly protected. So, exactly how often does an arc flash happen? More often than you might think. Consider this. 80% of all electrical injuries are from burns received from an arc flash and the ignition of flammable clothing. Arc flashes can occur in many industries, not only the electrical utility industry. In fact, they can occur anywhere that exposure to energized equipment is possible. The risks and exposures in these various work environments are different, but it is vital that all people exposed to the potentially dangerous electrical hazards know and follow all of the necessary steps to protect themselves. To help protect workers from the dangers of arc flash, several groups, including OSHA, the NFPA, and ASTM, directly address the arc flash risk with a series of regulations, specifications, and guidelines for protection of workers exposed to electrical hazards. The NFPA 70E standard is the most complete source for all safety concerns regarding arc flash. Federal OSHA requires the establishment of a program that protects against shock and arc flash when the potential for arc flash is present. OSHA may consider the employer to be in compliance if the electrical safety program is established and the proper PPE is selected based on the NFPA 70E standard. One of the biggest concerns about arc flash is how to effectively understand it and properly specify the right PPE for the hazard. Ensuring your workers and your facilities are in compliance can be an overwhelming task. This video will go over some of the necessary steps so you can confidently begin to create an electrical safety program for your facility. The first step is to determine if you are working within or near the flash protection boundary. What is the arc flash boundary? The arc flash boundary is one of the key issues addressed by the NFPA 70E standard. The arc flash boundary is the approach limit at a specific distance from exposed live parts within which a person could receive a second-degree burn. Workers may not cross this boundary without the appropriate personal protective clothing and the close supervision of a qualified worker who has the necessary certifications and has been properly trained. In addition to the arc flash boundary, there are shock protection boundaries. Shock protection boundaries function in the same way to protect workers from exposure to dangerous energized conductors. As seen in Table 130.4c and the illustrations, there are specified boundaries for limited, restricted, and prohibited approach. The arc flash boundary might be a greater distance from the energized electrical conductors or circuit parts than the limited approach boundary for shock protection. The shock protection boundaries and the arc flash boundary are independent of each other. The NFPA 70E standard defines the requirements for being a qualified person. Complete adherence to the information given in the NFPA 70E standard is critical to arc flash safety. In fact, with proper PPE combined with knowledgeable employees, the risk of an arc flash can be greatly reduced. The next step is to determine your hazard risk category or calculate the exposure you might face in the field. NFPA 70E offers two methods. First, hazard risk categories, reference 130.3, sections B, 1, and 2. And secondly, incident energy analysis. NFPA 70E has clearly defined hazard risk categories or arc flash ratings that help to determine the clothing needed to keep safe in different conditions. To determine the hazard risk category or arc rating, NFPA 70E requires an incident energy analysis of the job to be performed. Each situation is unique and needs to be evaluated. ASTM F1959 details the standardized test that must be used to determine the thermal protective value of textiles in an electrical arc application. Ensuring your workers and facilities are in compliance with OSHA rules and the NFPA 70E standard can be an overwhelming task. Salisbury Assessment Solutions, or SAS, can assist you with its expert assessment services, safety compliance, and training. SAS will make a site visit and perform customized assessment services based on OSHA requirements and the NFPA 70E guidelines. The SAS staff consists of experts who are highly educated, trained, and certified. SAS staff members have a long history in the safety community, along with numerous professional safety affiliations. Once the assessment is complete, each location is labeled with information as required by the NFPA 70E 2012 standard to help determine the PPE necessary to work safely. Salisbury Assessment Solutions also offers electrical safety training. Our on-site training develops and enhances employees' skills and confidence levels, increasing their qualifications to perform electrical work safely. This results in increased productivity, decreased downtime, and cost savings for your company. Salisbury's on-site training provides an opportunity for employees to continue expanding their knowledge base and troubleshooting skills. Once your shock and arc flash assessment is complete, you will know the hazard risk category or arc rating for that location. NFPA 70E 2012 breaks down arc flash hazards into multiple hazard risk categories. HRC 0 has a maximum exposure of 1.2 cal per centimeter squared. Without the proper arc-rated PPE, an electrical worker could receive a second-degree burn from an HRC 0 exposure. At HRC 4, exposures can exceed 40 cal per centimeter squared, where the risks are more catastrophic. Effects of exposure at the HRC 4 level can include third-degree burns over large areas of the body or even death without the proper arc-rated PPE. This is especially true on unprotected skin or when non-arc-rated clothing is worn. For those that survive the arc event, the long-term effects of such burns are overwhelming, often resulting in many months of painful medical treatment and extended rehabilitation. Despite surviving the initial arc event, many victims do not recover from the severe burns and ultimately face death from the initial arc exposure. In this next section, we will discuss the products offered by Salisbury that protect electrical workers as outlined in NFPA 70E. To meet the hazard risk categories, Salisbury by Honeywell offers equipment in values of 8, 12, 20, 31, 40, 55, 75, and 100 cal per centimeter squared, which will provide head-to-toe protection. It's important to remember that the lowest arc-rated product within the system determines the arc rating for the entire system. Let's take a look at what we offer. AF hoods are arc-rated balaclavas. They need to be worn under an arc-rated face shield with a chin cup and a hard hat to meet the NFPA 70E requirement of Hazard Risk Category 2. This provides the worker with 360-degree protection. Salisbury by Honeywell offers AF hoods sold individually or in convenient kits. Salisbury by Honeywell face shields are highly transparent for excellent visual clarity. Better worker vision helps create a safer work environment. The AS1200 face shield has a wraparound lens creating excellent peripheral vision. They absorb more than 99.9% of harmful UV rays. The AS1200 series face shield has a rating of 12 cal per centimeter squared. This face shield has a revolutionary weight balancing design that allows the shield to stow in a balanced compact position over the hard hat when not in use. This highly sought-after face shield is also available in a universal fit design for either front brim or full brim hard hats. The AS1200 series is also available with a transparent chin cup option for an increased viewing area. The AS1200 series face shields also have the option for attachable task lights and anti-fogging inner lenses, which completely eliminates fogging. These combined features make working conditions safer, comfortable, and allow for better productivity. Each Salisbury face shield comes with a pair of safety glasses that are to be worn with the shield. There are several clothing options available for HRC2. For example, arc-rated coveralls are an excellent option, as these garments have a hook and pile front closure and cuff openings, 2-ply arc-rated wristlets, and an expansion back for easy wear. Salisbury by Honeywell's coveralls are manufactured using industry-leading arc-rated materials. A second clothing option to meet NFPA 70E Hazard Risk Category 2 includes an arc-rated jacket with arc-rated overpants. With this option, the worker is also required to wear safety glasses and an arc-rated face shield, such as Salisbury by Honeywell's AS1200 hat shown here, protective gloves, hearing protection, and footwear. Salisbury by Honeywell offers an arc-rated jacket made from high-quality arc-rated material. The jacket has a hook and pile front closure and arc-rated wristlets. Ease the burden of selecting the right item for the job and meeting NFPA 70E requirements. Salisbury by Honeywell also offers convenient kits. These kits are available in arc ratings of 8, 12, and 20 cal per centimeter squared. Salisbury by Honeywell offers a coverall kit, jacket kit, and a jacket and overpants kit in these values. Each kit includes everything you need except for gloves, hearing protection, and footwear. All garment kits are available in numerous sizes and include specialized storage bags to keep the gear protected when not in use. All of Salisbury by Honeywell's garments fit comfortably over a worker's clothing, meeting ASTM F1506 standards and are CE 0120 certified. Another option to meet NFPA 70E Hazard Risk Category 2 requirements includes a switching hood, arc-rated coat, and arc-rated overalls along with proper safety glasses, hearing protection, gloves, and footwear. Switching hoods offer a layer of arc-rated material over the worker's head, neck, and upper chest. A balaclava is not necessary with these hoods. Salisbury by Honeywell's Pro hoods are made from arc-rated material and sewn with flame-resistant thread. The lightly tinted 10-inch by 20-inch lens wrap around the user for a large viewing area. The hood is attached to a hard hat for comfort and stability. The Salisbury by Honeywell Pro hood also has optional cooling systems. These systems help to cool the worker while working in warm conditions or confined spaces. The Pro hood is also available in a convenient kit that includes bib overalls, coat, safety glasses, and storage bag. All of these Salisbury by Honeywell garments meet ASTM F1506 standards and are CE 0120 certified. The Pro hood meets the ASTM F2178 face protection standard and the flammability requirements of the ASTM F1506 standard. The Hazard Risk Category 2 kits are available in 8, 12, and 20 cal per centimeter squared in numerous sizes. Now let's look at the necessary clothing to meet the Hazard Risk Category 3 and 4 requirements. The required option for Hazard Risk Category 3 and 4 includes a switching hood, such as Salisbury by Honeywell's Pro Hood Arc Flash Protection Hood, arc-rated coat, and arc-rated overalls, along with proper safety glasses, hearing protection, gloves, and footwear. These are the same items we reviewed in the last segment on Hazard Risk Category 2, but the arc rating of the material used to construct the garments and the protection values of the lenses in the switching hoods is increased to handle the increased energy associated with HRC 3 and 4 events. Salisbury by Honeywell's arc-rated coats and bib overalls are made from high-quality arc-rated material and sewn with flame-resistant thread. Salisbury by Honeywell's bib overalls have a relaxed cut for greater mobility, and adjustable hook and pile waist straps. The integrated suspenders are heavy-duty and are attached to the front bib, adding extra arc flash protection to the wearer. To meet hazard risk Category 3 requirements, the garments must have a minimum arc rating of 25 cal per centimeter squared. To ensure proper protection, Salisbury by Honeywell offers an NFPA 70E Hazard Risk Category 3 kit that has an arc rating of 31 cal per centimeter squared. To meet Hazard Risk Category 4 requirements, the garments must have a minimum arc rating of 40 cal per centimeter squared. Salisbury by Honeywell offers NFPA 70E Hazard Risk Category 4 kits that have an arc rating of 40 cal per centimeter squared. In addition, Salisbury by Honeywell also offers products with protection of 55, 75, and 100 cal per centimeter squared. These HRC 3 and 4 kits make it easy to select the proper PPE for each hazard risk category or incident energy calculation. Every clothing item can also be purchased individually if the entire kit is not needed. When it comes to PPE, Salisbury by Honeywell is the only manufacturer that can offer head-to-toe protection from the hazards of arc flash. The appropriate care and use of insulating rubber gloves and accessories is critical to maintaining worker safety when exposed to the risk of an arc flash. Salisbury by Honeywell offers a full line of rubber insulating gloves, leather protectors, and related products. Insulating rubber gloves are the first line of defense against contact with energized equipment or lines. For this reason, it is vital that you understand how to properly use and care for them. In addition, properly sized gloves are important to ensure worker comfort and maximize user dexterity. If you have any questions about how to choose the proper size of rubber gloves, please speak with a Salisbury by Honeywell representative or review our catalog pages for useful information about the care and use of electrical insulating rubber goods. Prior to each use, it is vital that you inspect your rubber gloves to make sure they are safe to use. Damage that has occurred to the gloves while in storage or during their last use could result in them being ineffective for protecting the user from electrical shock. The flaws you'll be checking for include cuts, punctures, ozone cutting, UV damage, embedded foreign material, oil contamination, or gloves that leak air when being inspected. Salisbury by Honeywell can help you understand and learn the inspection process to help ensure worker safety in the field. The other vital part of field safety is periodic electrical testing of rubber insulating gloves. This is done on highly specialized equipment, which is available at various independent testing laboratories around the United States. For information on a test lab near you, contact your Salisbury by Honeywell representative. The interval between electrical retest for rubber gloves, in other words gloves issued for service, shall not exceed 6 months. Gloves that have been electrically tested but not issued to employees shall not be placed into service unless they have been electrically tested within the previous 12 months. An important accessory for insulating rubber gloves are leather protectors. Leather protectors should always be worn over electrical insulating gloves to provide needed mechanical protection against abrasions, cuts, and punctures. Leather protectors should never be used as work gloves, and work gloves should never be used as leather protectors. Leather protectors are specially designed to fit over rubber gloves without pinching or stressing the rubber. By pinching or stressing the rubber, there is an increase in the likelihood of damage to the gloves from ozone. Leather protectors should be inspected for tears, cuts, open seams, grease and oil, embedded wire, or wood splinters that could possibly come in contact with the rubber gloves. Protectors should be replaced when they are suspected of having any of these conditions. Glove liners can help to make rubber gloves more comfortable to wear. They absorb perspiration when it's hot and keep the hands warm when it's cold. Glove liners are made from absorbent fabric and accommodate a range of hand sizes. Proper storage of the gloves between uses is very important. Rubber gloves should be stored in a glove bag, usually made of canvas, with air holes in the bottom to allow for proper ventilation. Do not store more than one pair of gloves in each bag. Also, do not store gloves near sources of heat, as this can damage the rubber. When putting the gloves in the bag, do not fold them.